Hello, this is Appendix 1 of Lecture 1, Unit 4 on digital real numbers under the Numerical Methods and its programming channel. My name is Ganapati V. Narayanan, or simply you can call me Narayanan. This video discusses the classical numerical methods using integers by so-called Vedic Math methods. These methods have been devised long time ago, and note that decimal numbers follow the same classical methods for integers, knowing that a decimal number is an integer before the decimal point and a whole number written after the decimal point. Before we go further, I would like you to subscribe to this channel by clicking the subscribe button shown below. In this video, I elaborate on Vedic multiplication rules only. Of course, other Vedic rules exist for addition, subtraction, and division, and squaring of numbers or cubic of numbers. We discuss the multiplication rules under this appendix using mostly two-digit numbers. This video is independent by itself, but also provides supplementary material to Unit 4 video of Lecture 1 under the Numerical Methods and its programming channel. Now, Vedic period and Sutras. The Vedic time period is between the year 2000 BC and 200 BC. Sutras were recited following the Vedic period, during the Vedic period, as part of various religious rituals. The word sutra, spelled as S-U-T-R-A, sutra, has the English translation of lineage or length chain as a thread chain of ideas or methods. Note that there are 16 sutras and 13 sub-sutras that are recited during the Vedic period and then written out on materials between the year 500 BC and 200 BC. These sutras are meant to provide classical rules of mathematics, as then it is called computational methods or numeric methods. We use these methods in the modern times as the usual arithmetic methods taught in our primary schools. There are 16 rules in the Vedic math, and I'm going to recite two of them that are useful for multiplication of integers. We discuss this supplement only for the Vedic multiplication rules, and the two important sutras that are useful for multiplications are, I call them as Vedic rule number 1 and Vedic rule number 2 on this video. The rule number 1, as it is stated in Sanskrit as Urdhva Tiryagbayam Prayogyam. Again, Urdhva Tiryagbayam Prayogyam. Urdhva is translated as vertically, and Tiryagbayam translated as crosswise. Prayogam means method. The second Vedic rule, as I call it rule number 2, is stated as Ekadikena Purvena Prayogam. Repeat, Ekadikena Purvena Prayogam. Eka is translated as one numeral, Ekadikena as one more than, and Purvena is translated as previous. So we can say this rule number 2 is one more than the previous rule. How these two sutras help in multiplication integers are detailed on the following slides. Before we go to the multiplications, one must note that the multiplication tables of digits must be memorized in order for successful multiplication of integers. This is the basic multiplication table of digits. We simply call it as multiplication table, and every person interested in math and developing numerical methods must know this fully in mind. We need to memorize only up to table 9 for all the digits. Table 1 is easy. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. And that's the second row that you see under the column 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first row is the multiplier and the first column is the multiplicand. And so the same table, third row is table for number 2, which is 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on, up to 2 times 9, which is 18. Same thing for 3, 3 times 1 is 3, 3 times 2 is 6, and so on up to 3 times 9 is 27. We can do up to table 9. 9 times 1 is 9, 9 times 2 is 18, and so on up to 9 times 9 is 81. I repeat, one must memorize this table in order for successful multiplication of integers. These Vedic rules, the classical times, have been generalized in pre-algebra or algebraic multiplication rules as used consistently in math multiplication of numbers, be it integers or the numbers being real numbers or the numbers being complex numbers. The two Vedic rules in the classical times are summarized as two algebraic multiplication rules in the modern time that are used consistently in the math today of multiplication of numbers. These rules, the classical rules of Vedic methods, are also called mental math methods that use these algebraic rules implicitly. These rules are stated below as A multiplied by, within the parenthesis, C plus D, and the multiplication is represented as a dot, and you could write this also in a computative format as C plus D times A. Of course, this is called commutative property, where the association of A and C plus D can be mutually transposed. If you distribute A inside the parenthesis, you end up with A times C, which is A dot C in this case, plus A dot D, or A times D. That is rule number 1. So we state A times C plus D equals A times C plus A times D. The rule number 2, which is an expansion of rule number 1, is written as A plus B multiplied by C plus D, which dot represents the multiplication, and we can distribute A and B individually as A times C plus D and plus addition of B times C plus D. And of course, we can use rule number 1 and then expand it further as A times C plus A times D, and then we have B plus B times C plus B times D. These two rules can be applied for any numbers. The number can be integers or decimals or complex numbers. I tried to enumerate the Vedic multiplication rules as 10 different methods, of course 9 different methods, and then the 10th one being multiplication of 3-digit integers as an extension to 2-digit integers. Of course, multiplication can be done with any number of digits, but knowing these, it would be possible to extend multiplication of any digit numbers. The method numbers are actually devised for this video so that it's easier to discuss the methods. But mostly method 1 through 9 deal with 2-digit numbers, and a special case of 3-digit number is given as method number 10 so that we can extend to any digit after knowing method 10. The method 1 is the general one, where it gives you the multiplication of 2-digit integers. Both the multiplicand and the multiplier are 2 digits. Then we go on with special cases and of shorter methods. Now, we also discussed the square of two-digit numbers, and there are three methods enumerated here and other special cases. So let's dwell into these methods and see how multiplications are done. The method number one is a general one where it shows the multiplication of two-digit integers. Of course, as I told you, we can extend this to decimal numbers, knowing that the decimal number consists of integers before the decimal and whole number after the decimal. And I do give this method and show it to you with examples in three different ways. So the first one is showing by actually multiplying with an example. So now we discuss the multiplication of two-digit integer. We use Vedic rule number 1, where it says that we first do the left digit vertical multiplication and then do the cross step digit multiplication, and then the third is doing the vertical right digit multiplication. So if, for example, we want to multiply 36 by 47, so let's write it out. So we have 36 and we have 47, and we want to multiply by the Vedic rule number 1. Then what we need to do is we have to take the left digit, which is 3, and then we multiply with 4, and then we use the cross multiplication of digits, which is 3 with 7, 4 with 6, and then add it up. So it is 3 times 7 plus 4 times 6, and then the last one we multiply 6 with 7 to get 42. And so of course we need to carry over numbers, because each location within the parenthesis, you see that there are no dots, which means that the parentheses adjacent to each other are just digits. And so if I go from right to left, we can see that the last parenthesis is 42, which means that number 4 is moved to the left, which is carry over. Now the middle parenthesis is 3 times 7 plus 4 times 6, which is 21, plus 24, which is 45, plus 4, which is 49, and then we carry over 4 to the left, and so you will become 1692 as the answer. I elaborate it once more using this example. Step 1, we try to do the step number 1, which is left multiply. So we multiply 3 times 4 to get 12. And then the second step is cross multiply. So we multiply 3 times 7 and then 4 times 6. And then the last one, we multiply the right digit, which is 6 times 7. And then we write it out with parentheses adjacent to each other with no multiplication symbol, which tells that each parenthesis should contain only single digit. But since it is greater than 10, we need to follow the carry over, which means that the 4 in this 42 is carried over to 45 to get 49, and then the 4 in the middle parenthesis is carried over to get 16. So the answer will be 1692. Now we can generalize the multiplication of two-digit integer using symbols, and you can see that the two-digit number A, B, and CD is written as 10A plus B and 10C plus D, and you can use the Vedic rule number 1, which is step number 1, vertical multiplication, and then the cross multiplication, and then the right digit vertical multiplication. And one can prove that this method does yield the result, and you can see that 10A plus 10C is 100AC, the cross multiply 10a times d plus 10b times c is actually written as 10 times a times d plus b times c. And then the third step, b times d, of course, we can write this simply because of its position. The 100 AC is the first digit of the result, a times c. The 10th digit is a times d plus b times c. And then the last digit is b times d of the result. And so we do get the result as shown on the previous slide and shown here. We can give other examples of multiplying any two-digit number, and without elaboration we can write 36 times 24 is 3 times 2, then cross multiply, then vertical multiplication to end up with the result 864. Of course, you could also write this adjacent to each other, and you can see that the step number 1 is the multiplication of the left digit, and step number 2 is the cross multiply and add. The step number 3 is the last digit number. Similarly, we can write 67 times 33 is 6 times 3, then 6 times 3 plus 3 plus 3 times 7, and then the last digit, vertical digit, is 7 times 3. So we end up with the answer 2211. Similarly, we can do 88 times 72. The left digit is 8 times 7. The cross multiplication is 8 times 2 plus 7 times 8. And then the vertical digit is 8 times 2. Then if we write the carry over, then we end up with the result 6336. We can also give one more example, 88 times 72. And of course, we could do it in a different format by splitting the 88 as 8 times 11, and then we can write 8 times 9 for 72. And so if you know the multiplication table, then we can say 8 times 8 is 64, and 11 times 9 is 99. And there is another rule that's coming up by which you can get the answer 6336. We continue with the multiplication of two-digit number by method 2, which I call it as a mental method, which means you could do it in the mind without a piece of paper, but I suggest using a piece of paper. And this is a shorter method compared to the previous one. Take an example of two-digit number and use method number 2, and the example is 43 times 52. In this method, we assume a base number. The base number is any number that's a multiple of 10. And so let's see how we use this method and see how it is shorter than the previous method. So we write 43 times 52, and we take the base b as 40. So we subtract 43 from 40, and we subtract 40 from 52, and so we end up with 3 for the first number 43, 3 above the base 40, and the second number 52, 12 above the base 40. And so if we see that add the cross numbers, so 52 plus 3 is 55. Same thing, 43 plus 12 is 55. And so we end up with the result of 43 times 52 as 55 times the base plus the multiple of 3 times 12. And so we end up with 2200 plus 36, which is 2236. And so in this method, the shorter way is just multiplication of two numbers. One is the number above the base, multiply two numbers above the base. So if I say that the base is b, and let a symbol e equals 43 minus base, which is 3, and then let f equals 52 minus b, which is 12. Then this makes the multiplied 43 times 12, 52 is 55 times the base plus the difference from the base of the two numbers, which is 3 and 12. So we end up with 2336. Now we can express the multiplication of two digits by the shorter method 2 using symbols. If they are given the two numbers AB and CD, then we can assume a base B. Then the first number AB is above the base B, and let's represent that by symbol E. E is AB minus B. And then the second number above the base, let's represent by F. Then we can say that AB times CD is nothing but AB plus F or CD plus E, whichever you can take, times the base plus E times F. And of course, I have shown this with an example on the previous slide. I can give more examples under the method 2, but before we do that, let's see other methods which are nothing but the special cases of the two-digit numbers. So in this case, let's say we want to multiply any digit by 11. So if we want to multiply any digit by 11, say for example, we want to multiply 375 times 11. And so let's write 375. Let's write 375 times 11. So what we do is we take the first number and write it as is. Then we take two numbers and then add it up. And then we take the next two numbers and add it up. And then we write the last number and then use the carry over. So this will be 5, that will be 2. And then we carry over, that will be 1, 11. So that will carry over, and that will be 4. So the answer will be 4125. 4125. So we write it in words, this method, this Vedic method. We write digits starting from the left digit. So we write digits starting from the left digit 3 of 375. Then add the two digits at a time. First 3 plus 7 and then 7 plus 5 until we end up with the last digit 5, and then use carry over to get the result 1425. We can show the same thing in terms of symbols and prove that the method works by writing down as stated. And so if we use the symbols and start with AB, then we can multiply with 11 with the same times. So we write the other examples, 23 times 11. We write the left digit 2. Then we add the two digits 2 plus 3. Then we write the last digit. So the answer will be 253. If I write 348 times 11, then the left digit is 3. The next two digits are 3 plus 4. The next two digits are 4 plus 8. And then the last digit is 8. And so we end up with 3828. If we have more digits, 4296, we can carry out the same thing. The left digit is 4. And then we add up 4 plus 2 as the next digit. Then we add up 2 plus 9 as the next digit. And then we add up 9 plus 6 as the next digit. And then we end up with 6 as the last digit. Of course, we use the carry over and get the result as 47256. You can think of method 3 in terms of the algebraic rule, in terms of algebraic rule 1, and you can write 22 times 11 and expanding 22 as 20 plus 2 times 11. Then we use rule number 1 and we write 20 times 11, distributing 11 inside, and then 2 times 11 is 22, so you end up with 242, which is the same thing as writing the left digit 2, Then adding 2 plus 2 is 4, and then the last digit is 2, and ending up with 242. Same thing we can write 68 times 11. 68 we write it as a sum, 60 plus 8 times 11. Use algebraic rule, 60 times 11 plus 8 times 11, and then we end up with 748. This Vedic rule is applicable to any number of digits in the multiplicand. Multiplicand means the first number. The multiplier is the second number. Now we continue with the next method, which I call it as method 4. And of course, the multiplier being 11 is a special case of this method. And this method, you can use the multiplier as any number greater than 11. So it can be 12 through 19. This is also a shorter method, but it's little longer than 11. We can see how it is done with one example here. Then we will continue. Now, under this method, we can multiply any integer by 12, 13, 14, or 19. So let's take an example. So let's take an example of 423 times 12 and see how the multiplication is done. So we take 423 times 12. So 423 times 12. And so what we do is we go from left to right and take the digits one at a time. So we take 2, and then what we do is think of 0 as the first digit, and so we multiply 0 times 2 plus 4 as the left digit. Then we take the two digits 4, 2, and then we multiply 4 times 2 plus 2, and then we have the next two digits, which is 2 and 3. So we say 2 times 2 plus 3, and then the last digit is 3. If I say that the next digit would have been 4, then it would be 3 times 2 plus 0. But of course, there are no digits in the front and the back, but we only take 2 digits at a time. So you can see that the methodology uses the number 2 as the multiplier of taking 2 digits at a time. And so in the previous case, for 11, we used the multiplier 1, and so we ended up with just adding the numbers, 2-digit numbers. But now we have to separate the 2 digits. One left digit you multiply with 2, and the right digit you multiply with the right digit, you add it up, and so you will end up with the results. And so you see here that 423 times 12, we take 0 times 2 plus 4, and then we take 2 digits, but the left digit is 0, and then we take the next 2 digits, 42, and then we multiply the left digit by 2, add the right digit, and then we take the next 2 digits, which is 2, 3, then we multiply the left digit by 2, add the right digit, and then we think of the right digit. There are no right digits, and so we just end up with 3 times 2. And if we write it with between the parentheses, and you can have only one digit, which means that we have to use the carry over. And you can see that this is 10, so the carry over to the left, so the 4 becomes 5, and so we end up with 5076. So the magic is this, where the left, we take 2 digits at a time, and the left digit we multiply with the number, whatever multiplier that we have. Either 12 means 2, if it is 13, then the digit is 3, and so on. Then add the right digit and adjust for carry over. Of course, we can do it with in the simple format, and this follows the same procedure as the previous in terms of simple format. And so let's see how we multiply digit AB with one question mark being any integer between any digit between 2 and 9. The step 1, we write the left digit as is. So if I take the example 34 times 12, we write the left digit 3 of 34. The step 2, multiply the question mark number. So in this case, if the multiplier is 12, then the digit is 2. And then we take 2 digits at a time. So we take 34 and we multiply 3 times 2 plus 4. And then the right digit we multiply with 2, and so you get the answer 408. If it is 3-digit number, then we have the left digit as 5, the next 2 digits 5, 4. So we multiply, if we multiply by 14, then the right digit of 14 is 4, so we multiply by 4. The left digit of 54 is 5 times 4 plus 4. And then the 2 digit, if I take 42, then the left digit is 4, so 4 times 4. And then we add 2. The right digit is 2, so it is 4 times 2. And we get the answer 758. Similarly, we can do 4-digit number and so on. We can take more examples with different digits. So here we will take the multiplier as 13, and of course we can do the same thing. So we first start with the single digit 5, which you can consider as the right digit, and then the left digit is 0. So 3 times 0 times 3 is the ending number digit of 13. And then we use 3 as the magic number, and so we take the next 2 digits as 53. So the left digit is 5, so we multiply 3 by 5, then add 3. Then we take the next 2 digits as 35, and so we have the left digit of 35 is 3. We multiply with 3, then add 5. The last digit is 5, so it is 5 times 3. And then we end up with 5, 18, 14, 15 as the numbers. We use the carry over, and then we move 1 to the left, and then 1 to the left, and 1 to the left, and so we end up with 6955. We can do the same thing for multiplier 16, and the magic is multiplying 6, taking 2 digits at a time, and we end up with 10,992. Of course, we could also use the algebraic 2, and if we use the algebraic 2 in the modern approach, then we can split the number as a sum. So we can just say that 535 times 13 is equal to, so let's write it out. We can also use the algebraic rule 2, and use the expansion of 535 as a sum, and then multiply with the expansion of 13 as a sum, 10 plus 3. And let's see how we do this on paper in more elaborate manner. So we have 535 times 13. We can write this as 500 plus 30 plus 5 times 10 plus 3. So what we can do is we can use the distribution rule, one digit distributed inside. And so let's say we have 500 and we take it inside 10 plus 3. So we end up with 5,000 plus 1,500. And then we use 30 and distribute it inside. So we get 300 plus 90. And then we take 5 inside this number. So we get 50 plus 15. And so if you add up, you can see that 5000 plus 1500 plus 300 plus 90 plus 50 and then 15. So if we add up, we will end up with 6900. So that's what I wrote here. 535 times 3 is 500 times 3. So it is 5350. Then this. So what I did was I distributed here 10 first inside and 3. So it's easier. So you end up with same thing we can do for other methods. And you can see this. Now we go on to the shorter method of method 5, I call it. And this has to do with multiplying any digit by 99. This is the simplest multiplication by Vedic rule. And so let's see how this is done. If you multiply two-digit number by 99 by the shorter method, then this is much shorter. If you can think of 99 as 1 less than 100, and this is applicable for any multiple of 10. In this case, any multiple of 10, in this case it is 100. And so let's see how it is. So if I say the number is 45 and I want to multiply with 99, you can express this as algebraic rule number 1, 45 times 100 minus 1. And so this is actually 4500 minus 45. And so you can see that 45 is subtracted from 4500, which you end up with 4455. And 55 is a complement of 45, and we subtract 1 from 45 to get 44. So the answer is 4455. So in this case, the example 45 times 99 is 1 less than 45 on the left digit, and then the complement of 45 as the right digit, and so you end up with 4455. The reason we do not carry over in this case is 100, when you multiply with 45, it is 4500. So the position of 44 is correctly placed, and then we end up the last two digits as the complement of 45. Same thing we can do 68 times 99. We take 1 less than 68 on the left side, and then complement of 68 is 32. So we end up with 6732 as the answer. If I multiply 99 times 99, then the left two digits are 98. Then the complement of 99 is 1. So the answer is 98. We go on to the next method, which is squaring of two-digit numbers. Of course, squaring of any two-digit number is actually multiple of the same number. Multiplicand and multiplier, they are the same. And so we can use any of the above methods of multiplying the two-digit numbers. But we will see a shorter mental approach to getting the result of squaring two-digit number. Let's say we have to square number 67. So what is the value of 67 squared? So what we do is we take the number 67 and add, increment or decrement a number that's closer to a number multiple of 10. So in this case, 70 is closer to 10, and so we add 3 and then we subtract 3 and we get the two numbers 70 and 64. We multiply 70 and 64, and then we also, whatever the number is incremented or decremented, we square them and add them, and so the answer is 4487. We can see more examples, but before we do that, we can also generalize it in terms of symbols. So if I say the number is AB and the increment and decrement is a digit d, then we can represent E as AB plus D and symbol F as AB minus D. And then the result will be E times F plus D squared, and that will be the result. So in this case, if I say 67, as I said in the previous video, we say the number is 67, then the increment or decrement is 3. So E is 70, 67 plus 3. F is 67 minus 3, 64. And so we multiply 70 and 64 and add the incremental digit squared, which is 9, and get. We use the seventh method for squaring a number that ends with digit number 5. So this is a much simpler than before method, and let's see how this is done. So if we take an example of a number that ends up with 5, say 85, then of course by the previous method we could find the increment and decrement as 5 and follow that rule, or we can use a shorter method where we increment the left digit by 1. So if I increment left digit by 1, that is 9, and then we multiply the left digit with the incremented number. So increment 10th digit, this is 8, is the 10th digit. So we increment by 1 and multiply, so it is 8 times 9. And then we write 25 to the right, that is 5 squared, and so we end up with 7225. We can have more examples, but before that we can do this with the symbol AB and 5, and as previously we can prove that this is the same thing as increment 10s by 5. So let's say E is A5, A5, B is 5, so it is A5 plus 5, and so we can write this as 10 times A plus 1, because 5 plus 5 is 10, so 1 is carried to the left, and so it is the A is 10th digit, so it is 10 times A plus 10, which is 10 times A plus 1. We can talk about squaring a 2-digit number ending with 5, and we can use the Vedic rule 2, where it says one more than the previous. So which means that we can, let's take an example. So if I have A, B, let's write it out. If I have A, B, then we want to multiply with A, B. So what we want to do is this number is ending with 5, and so we add 5 and subtract 5. So when we add 5, so 5 plus 5 is 10, and of course this can be written as 10, the digit is A, and then we add 5, and so we end up with 10A plus 10, and so we can write 10A plus 1. If we add, we get 10A plus 1, and if we subtract, then we get just 5 is subtracted, so it is just 10A. You end up with A5 times A5 is A into A plus 1, and then 25 is just written on the side. So we increment the left digit by 1. So this example we showed in the previous slide. You can give a lot more examples of squaring a number, and this you can do very much mentally. If I say 25 squared, the left digit is 2, so we increment by 1, so we end up with 2 times 3, and then write 25 beside, which means 2 times 3 is 6, 625. Same thing with 35, which is 3 times 4 on the left side, which is 12, write 25 on the right side. 45 squared, increment 4, then multiply with 4, and so it is 4 times 5, write 25 beside, so which means 2025. And you can also do for 3 digits. If it is 225 squared, then you multiply 22 times 23. 23 is an increment of 22, then right beside 25, and so you get 50,625. The method 8 is similar to the previous one when you square a number with units adding to 10 and keeping the tens digit the same. Let's see an example. So we can generalize it right away. So if I have 10a plus b, and then we have 10a plus d, that is two digits ab, ad, a being the first, the tens digit being the same, and then adding the units digit b plus d equals 10, then we can get the answer as previously, where we increment the first left digit and then multiply by the right digit to get the answer. So let's write it out and see with an example. 73 times 77. So we have 73 times 77. Note that the first digit is the same and the tenth digit is the same, and the units digit 3 plus 7 add up to 10. So if such is the case, then we increment the tenth digit by 1 and multiply with 7. That will be the left number, and the right number will be the multiplication of 7 and 3, which is 21. And so which is 7 times 8 is 56. 21 is the answer. So we get 56. 73 times 77 is 7 times 7 plus 1, and 21 is written as the right two-digit multiplier, so we get the answer 5627. Now we can have more examples. If I have 36 times 34, then we can increment 3 by 1, and so we get 3 times 4, and then the last units digit is 6 times 4, so you can write 1224 as the answer. If I have 67 times 63, the first digit is the same 6, so we increment the 6 by 1, so which is 7, so we multiply 6 times 7, that's the left digits, and then the right digit is 7 times 3, which is 21, so we get 4221. Of course you can have 3-digit number, so if I have 124 times 126, the left two digits 12 is the same, so we multiply 12 times 13 as the left digits. The right digit is 4 times 6, so we get 15624. Of course, note in all this that parentheses are shown with adjacent digits. This is similar to the method of squaring with ending with 5, except the ending digits are varying depending on the given number. Now we talk about method 9, and this method is much simpler than previously, and we have used this before, where we multiply. The multiplier is 1 less than the power of 10. 1 less than the power of 10. So let's see an example. It can be 1 digit, 2 digit, 3 digit, whatever number of digits. When the multiplier is 1 less than the power of 10, then it becomes much easier. If I have the example 8 times 9, then what we can do is we take 1 less than the first left digit, which is 8 minus 1, and then we take the complement of 8, and so you end up with the number 72. Of course, if you take a larger number, it takes a little while, so you can take a piece of paper and see what's the complement of 36. And so we know that the complement of 36 is 64. We subtract 1 from the given multiplicand, so 36 minus 1, so we end up with 3564. It can be a larger number, so if it is 433 times 999, then we have to find what's the complement of 433 with a piece of paper, and that is actually 567. We subtract 1 from the given number 433 of the multiplicand, and so you end up with the left digit as 432. We can have more digits, and the method is the same. The 10th method is actually an extension of 2-digit number to 3-digit number, and of course the method number 1 we saw for 2 digits, multiplication of 2-digit numbers in general. We are going to extend it where there are going to be more cross multiplications and the left and the right digit multiplications remain the same. We use the Vedic rule, and the Vedic rule states as Urdhva Tiryagvyam Prayogam. Urdhva means vertically, Tiryagvyam means crosswise, Prayogam means method. So we use the Vedic rule now and explain this type of multiplication on 3 digits. Of course, we use some notation so that I can simplify this on the slide. So I use capital X for cross, that means multiplication, and symbol N2D, capital N2D, seen here at the top, where we say digit number of digits, 2 digits at a time, and then we have X N3D, that means we have number of digits, we have to use 3 digits at a time, and then we use X cross N2D, the next 2 digits, and then we vertically multiply the right digits. So if we have perform the multiplications, and let's take a blank sheet of paper and see how this is done in a little more detail and come back to this slide. Now we have 543 multiplied by 472. 543 is called the multiplicand, 472 is known by multiplier. So we take the first digit, in this case 543, the first digit is 5, and we take the first digit of the multiplier, which is 4, and we multiply it vertically, so we do the vertical multiplication. So 5 times 2 is 20. Now we take that first 2 digits of 543, which is 554, and we take the 2 digits of 47, and this next 2 digits we multiply by 47, so which means the result will be, and we cross multiply, so which means that the result will be 5 times 7 plus 4 times 4. And then we take the 3 digits together, in this case the 543 by itself and 472 by itself, and we use the cross multiplication. And in this cross multiplication, if I write it in a larger format, so I can show you the cross multiplication with 5 and 2, 4 and 3, and 4 and 7. And so we end up with 5 times 2 plus 4 times 3 plus 4 times 7. Now we take the next 2 multiplication, next 2 digits, and now if you move away from 5, so we end up with 43 as the first number, first integer. The second one is 72, and we do the cross multiplication. Similarly, 4 times 2 plus 7 times 3. And we take the last digit, vertical multiplication, and so the last digit is 3 of the multiplicand, 2 of the multiplier, and so we end up with 6. So the result is 20, and then 5 times 7 is 35 plus 16, which is 51. And then 5 times 2 is 10, 4 times 3 is 12, so it is 10 plus 12 is 22, plus 4 times 7 is 28, so 22 plus 28, which is 50. Next one is 4 times 2, which is 8, and then add 7 times 3, which is 21, so it is 29. Then 3 times 2 is 6. We do the carry over and carry it to the left of the digit because we need single digit within the parenthesis. So the first one is 6, the second one is 9. We carry over 2 here, the left. So 50 plus 2 is 52. So we carry over the 5 to the left. So 51 plus 5 is 56. So we carry over to the left, and so we end up with 5 and then 2. So the result will be 256296. So we come back to this slide. Now you can see what I have done on the other sheet by hand. So first thing is left digit multiply vertically, and so this is 5 times 4, 5 times 4, which is 20. And then we take 2 digits at a time and multiply. So the multiplicand is 5 times 7. The cross multiplication is 5 times 7 and 4 times 4, which will be 51. And then we end up 51 shown here. Then we multiply 3 digits at a time. 5 times 2, 5 times 2 plus 4 times 3 plus 4 times 7, and we end up with the digit 50. And then we do the next 2 digits, which is 43 multiplied by 72. So 4 times 2 plus 7 times 3, which is 29. And then we multiply the last right digit, 3 times 2, that is 6. And we carry over the we perform the carryover, and so we end up with 2562. Now I'm going to give 2 references for the Vedic rule. Of course, this is only Vedic multiplication of 3 digits, but you can get more details on other types of multiplications. And I have put videos of the other multiplications, but you can use these references also as a supplement to these videos. The first one is the Udemy course on mental methods by Vedic Math taught by Kosh. This is a 5-hour video course, and of course it doesn't cost much. It may be $10 to $15 on Udemy. The second one is a book on the essentials of Vedic Math, written by Rajesh Kumar Thakur, who is a director of National Vedic Math Academy in India. And this book is very detailed in explaining Vedic math and applications in all areas of math, of multiplication, addition, subtraction, subtraction, square root, cube root, etc. Thank you very much for watching this video, and look forward to meeting you in other videos.